Welcome to Signal Science System subject classes. Now we're in the third chapter, that is Fourier continuous time Fourier series. Previously we have discussed about Fourier series representation and Fourier series coefficient, everything. I have given information regarding problems and properties, especially we learn the properties of the Fourier series. And also we done some problems on the Fourier series. So in this video, we're going to discuss previous year questions. So these are the asked in UPSC engineering service examination in electronics and communication stream. So in the first question is, see here, so which one of the following is a Dirichlet condition? So this Dirichlet condition is nothing but convergence of the Fourier series, is it? The Fourier series. So before applying the Fourier series for the particular period signal, it must be satisfy the conditions. So that is nothing but convergence of the Fourier series. So these conditions are called as Dirichlet conditions. Here we have three Dirichlet conditions. The first condition, that is integrable. So the integral of minus infinity to plus infinity mod of x of t into dt, it must be integrable, means it must be finite value, is it? So this is the one of the condition. And the second condition, within the time period, it should have the finite number of maxima and minima. The third condition is it should have the finite number of discontinuities, is it? So the first one is this is integration mod of x of dt, but it is from the t1 to infinity, is it? It must be minus infinity to infinity, is it? So it is wrong. The second one is signal x of t must have a finite number of maximum and minima in the exponential interval. Is it? Signal must have finite number of maximum and minima, is it? So this statement is correct. So third one, x of t can have an infinite number of, is it? It is wrong. So x square of t must be absolutely summable, not x square of t. That is x of t. So it is also wrong. So the option is second one. The next question, a waveform is given by v of t equal 10 sine 2 pi under t volts, which will be the magnitude of the second harmonic in as Fourier series representation. So he is asking the magnitude of the second harmonic, is it? So you know that we can easily write trigonometric to the exponential. See, so this v of t, so v of t equal to 10 sine of. So here this 2 pi, this is a linear frequency. 2 pi f into t, here I am writing 10 into sine omega naught into t, is it? So now, so writing this trigonometric signal, so sine signal into the exponential. So 10 into, so sine theta, that equal to e power j theta. So j theta plus, sorry, minus, for the cos it will be plus. So minus e power minus j omega naught t by 2j. So here the omega naught equal to 2 pi into 100. So in expansion, so 10 by 2j e power j into 1 into omega naught into t. Next minus 10 by 2j e power j into minus 1 into omega naught into t. So this is a Fourier series coefficient. So Fourier series representation, is it? So v of t, it has been written in terms of the Fourier series representation, is it? So this k equal to 1, here k equal to minus 1. So this is first, so k equal to 1. So this is first harmonic. So it is also first harmonic, but it is in the negative side, is it? So the signal, so the signal doesn't have second harmonic. Okay, it is having only first harmonic, is it? But the second harmonic it goes to zero, is it? So the magnitude equal to zero. The next question: the Fourier series of a periodic function xt of t with a period t is given by, so Fourier series representation where 2 omega naught is given, the Fourier coefficient is given, is it the Fourier series formula? So this is the some information is given like Fourier series representation, its Fourier series coefficient formulas are given in this first statement. Next, if xt of t is a real and odd, the Fourier coefficient x k. See, in our subject, we have taken this x of k, we have taken like a k, is it? We have taken a k, is it? So here this x of t is a real and odd. For that, what is the Fourier series? So Fourier series coefficient. That is a question. Already we have discussed in the properties. So see, x of t real and odd, a k purely imaginary and odd, is it? So this is the property. Already we studied in the. So x of t, so direct question, this is the direct question. So this, if x of t is real and even, so this Fourier series coefficient, ak is real and even. If x of t real and odd, so this ak purely imaginary and odd, is it? So this is the answer. So the first one is real and odd, it's wrong. Complex, yes. So it is a purely, so complex means aj, the ak that equal to aj into j into bk, is it? So this is the real and this is the imaginary part, is it? Real, it's wrong. So imaginary, so j into bk, like this, is it? So imaginary, purely imaginary, it is not complex, is it? That you should remember. So option is second one is B. So next question. Consider a continuous time period signal x of t with the fundamental time period t and Fourier series coefficient x of k. What is the Fourier series coefficient of the signal? Is it? So this in the question is given that x of t with Fourier series coefficient that equal to ak. Then what is the Fourier series coefficient for the y of t? Is it? So y of t Fourier series coefficient. You know that this y of t, so this y of t equal to, so x of t minus t naught plus x of t plus t naught, is it? So this x of t I'm taking as a ak. So here I'm taking this x of t minus t naught. Its Fourier coefficient is bk. So here I'm taking like a ck. The sum of the bk plus ck, the dk, is it? So we have to find this dk. So first of all, this x of t, Fourier coefficient. See this x of t, its Fourier series coefficient equal to ak. Then x of, so x of t minus t naught, its Fourier series coefficient, So time shifting, is it? Delayed signal. So delayed signal. So it's nothing but ak into e power minus jk omega naught into t naught. It delayed by the t naught units. That's you should take. So this is equal to bk. Is it? The next one is x of advanced signal of the x of t by the t naught unit. So x of t plus t naught. So this is the advanced signal to the x of t. So this advanced signal for a delay you take the minus, for advance you should take plus, is it? So ak into e power jk omega naught into delayed units. How much? T naught. It is not delayed, advanced t naught, is it? So this is we have taken what we have taken so this is equal to ck, is it? So the final resultant Fourier series coefficient dk equal to bk plus ck, is it? So that equal to ak into e power minus k omega naught into t naught plus ak into e power jk omega naught into t naught, is it? So ak is a common. So ak is a common. Here I am writing this. So this is e power j k omega naught t naught plus e power minus j k omega naught into t naught. So this is a e power j theta plus e power minus j theta by 2. It becomes cos. So there is 2 is missing, is it? So multiply. So here multiply and divide, is it? So 2 is missing. So 2 by 2 gets cancelled, is it? So 2. So the resultant. So dk equal to 2 into ak into cos of k omega naught into t naught, is it? So this is it? So 2 cos. So 2 cos. So this is omega naught k t naught into x of k. You know the x of k is nothing but ak, is it? So the option A. The next question, the complex exponential form of the Fourier series of the x of t is given. Omega, okay. If x of t equal to sigma del of t minus b, then the value of ak, is it? Already we have done the problem similar to this one, is it? So that is, we know that. So impulse train, the Fourier series coefficient for the impulse train, for example, x of t, it is an impulse train like this. Del of we have taken in the previous case n of capital T. So n from the minus infinity plus infinity, is it? So it is nothing but minus. So n here varying from the minus infinity. So it is nothing but it gives the infinite impulse signals. It is for the right-sided impulse, right side shifted impulses and left side shifted impulse signals. Is it? This is called impulse. The time period equal to this the capital T. Its Fourier series coefficient equal to, already we have done this problem. So directly, this is Fourier series coefficient ak, for example, ak that equal to 1 by t. Is it? So compare this one. So this here the b from the minus infinity. So here it is similar to the n. Is it? So there is no coefficient here. Is it? So this is t. So capital T equal to 1. Is it? So Fourier coefficient, the Fourier series coefficient for this signal that equal to 1 by t. So that equal to 1 by 1. Is it? So answer is C. So these are the previous year's questions asked in the engineering service examination, which is being conducted by the UPSC in electronics and communication stream. So then in the last class, in the next class, we will discuss revision on this continuous time Fourier series. Thank you.